Okay, this is for Zamora. Again, I was planning on just doing problem 4 because it's a proof, but then I saw that there was a question about problem 3, so let's take a look at that first. Can two different concentric circles ever be tangent? Let me just make sure. Yeah, can two different concentric circles ever be tangent? Okay, so let's say we have two concentric circles. Hopefully you figured out what concentric means. Centric relating to the center, concentric meaning they share the same center. All right, so let's say we have one circle here with center O, and then we have another circle that is concentric. In other words, it shares the same center. All right. Now, again, you have to pretend that I'm actually doing a good job drawing these. So then that means that if they share the same center and they're different, right, that means their edges should pretty much be parallel right here. Right, again, that's not a good drawing, so just do better than I did. But if they share the same center, that their edges must be parallel. And again, I'm not sure that parallel is the best word here. If we had two different circles that maybe weren't like that, let's say we had this one as center O, and then this one got much closer here, so that I like to draw these while I'm on the video, but I'm really pretty bad at that. So if we ended up with one where they were not parallel, where it got a lot closer right here, they clearly can't share the same center. This right here is the center of the larger one, but this right here would be the center of the smaller one. So if we want them concentric, their edges kind of have to stay equidistant from each other. So let's say that's 1 inch. It should stay that way the whole way around if you've drawn them properly, right? So, so can two different concentric circles ever be tangent? Again, what does it mean to be tangent? It means that they touch in one spot, right? So we could make two different circles that were tangent, right, where they come up. And again, remember, it means it doesn't intersect it in more than one place. It only intersects it in one place. I can have two different circles that are tangent, but then they're not concentric, right? I can have two different circles that are not concentric, that get close to touching each other, or I could even have two different circles like this. Let's say we've got that one, and then we've got one that's inside it where they're tangent in one place. But again, then they're not concentric. So if we want two different circles to share the same center and have a point of tangency, again here, let's do this one. It's got that center O. If we want them to share the same center and have a point where they touch in one spot, all right, then I'm going to have to draw this right here so that their edges touch right here, and let's say this place right here. But then the problem is they're not different circles. The only way that if they share the same center, they can touch on the edge is if they're the exact same circle. Right, so the answer to this one is no, it's not possible. We can think of lots of different situations. One here where they are concentric and they are different circles, but they're not going to be tangent. There they won't intersect at all. Here we can have two different circles, a smaller one inside of a larger one, where we don't have that same kind of perimeter, you know, or equidistant space around the edge, but then they lose the concentric part. Here we can have two different circles that do share a point of tangency, but they are not concentric. Here again, inside, we could have two different circles that share a point of tangency, but not concentric. This one, we would have two circles that share the same center that have a point of tangency, many points of tangency, but they are not different, right? So the answer to this would be not possible. All right, as soon as we get them concentric and touching, let's do that again, concentric and touching, tangent, then they cannot be different. All right, so we have to get rid of one of these requirements in order to be able to do that. But with all three of those requirements, different concentric circles cannot be tangent. Okay. Problem 4 in Zamora, a proof again. So from a point that is outside the circle, there are two tangents that may be drawn to the circle. So we're given some point P that's outside the circle, and it's saying that we can find two places where it touches the edge of the circle but does not cross through it. And there are only 2 points where that will happen. For example, this right here would not be a point of tangency for P. If we went there, we would go in the circle and exit in another side. So there are only 2 places where that could happen, and we're going to call those A and B. All right, and it's asking us to prove that those segments, right here, from the point that connects to B and from the point P that connects to A, we're trying to prove that those two, AP and BP, are congruent. All right, so our given is we have tangents PA and PB to the circle O, and that's what's given. Okay, so in statement 2, we're going to say draw OA, OB, and OP. Right? We're used to drawing OA and OB. We've done those multiple times, but now we're also going to draw OP. Right? The reason we can do that, 2 points determine a line. All right, step 3. And again, I'm hoping that you're thinking about these, not just copying down as I do that, but as we've just drawn those, what are some things that you notice, and what are some things that you can say about this? So hopefully you've noticed that by drawing those 3 line segments, we've made 2 triangles right here. So that should kind of give you an idea of the direction that we're going to head with this. You should also know, because we've stated this a number of times in previous proofs, that OA and OB are congruent. So let me just write that. OA and OB are congruent. And the reason for that is all radii are congruent. All right, again, now that we know that we have these 2 triangles that are formed, what else could you say? Again, ignore the circle part, that's new to us, but the triangles are old hat. So what can you say? All right, so hopefully you can say that OP is congruent to OP. This is our POC, reflexive property of congruence, that it is congruent to itself. When I put those 2 hash marks there, I don't mean just this segment outside the circle. I mean the whole thing is congruent to itself. All right, this next step is new to us. And we need the fact that this is on a circle and these are tangents in order to do this one. We're going to say that OA is perpendicular to AP, right here. We're also going to say the same thing for the other side. OB is perpendicular to BP. All right, think about that for a second. Remember, you read this in one of the worksheets, I am pretty sure. I know you've read it somewhere, I'm just not sure if it's the worksheet or the textbook. And the reason is that this is just kind of the definition of, or not a definition, but it follows from that at a point of tangency, a radius is perpendicular to that tangent, right? So it's called a tangent. We don't have a number for this as far as I know. A tangent is perpendicular to a radius at the point of tangency. Okay. Now what do you think? Hopefully you can say that triangle POB is congruent to triangle POA. Forgot my triangle symbol in here. Reason, HL. All right, we have 2 right triangles here. Actually, no, sorry. We're going to put this in here. I don't have any super good erasers here. I'm in Abby's room hiding from the cat. Sorry, we do need to say one thing first. And that is that we need to say that angle PAO and angle PBO are right. All right, and that's definition of perpendicular. Okay, now we can say triangle POB is congruent to triangle POA. Reason is HL. Okay, and then we can say, once we know that these two triangles are congruent, all matching parts or all corresponding parts are congruent, so we can say that segment PA is congruent to segment PB by CPCTC. Cookie by cookie tart cookie. And that is the end of the proof. All right, thanks.